51. Okay. So now let us quickly start our first session, and I will start uh, with some mathematics related to binary and hex. You know that uh, we would be doing programming in microcontroller, and normally in assembly language we use the numbers in hex or binary form. So it is important that you are acquainted with the various mathematical operations and how they they happen when we are dealing with hex numbers or binary numbers. So you all know, definitely you all know most of the mathematical operations related with the decimals, the decimal number. Um, you must know that any number can be represented in various bases. Say, for example, if I'm writing down these numbers 1, 2, 3, 4, 5, and so on. So we normally assume them, uh, we even don't say that they are actually numbers in base 10. Okay. We, we just assume them to be in base 10. But these same numbers can be represented in different bases also, in base 2 or base 8 or 16, and their representation, it differs in all the different represent base representation system. Say, for example, I'm using base 2 and I'm interested in representing these numbers. So 1 can be represented as 1 and 2 can be represented as 1 0. Similarly, 3 can be represented as 1 1, and 4 can be represented as 1 0 0, and so on. And if I am dealing with, say, octal representation of these numbers, the same numbers, they can be represented as 1, 2, 3, 4, and so on till 7. There is no problem. So when I reach 8, then I won't be writing here 8. I would be writing 0, 1 0 rather. Okay. And then 1 1, 1 2, and so on till 1 7. And then again I will be writing 2 0. So these are all in octal base. Fine. Similarly, when I am representing the number in hex, I would be writing the same numbers 1, 2, 3, 4, 5, and so on till 9, no problem. But when I write 10, so I won't be writing it in decimal form. This 10 is basically what we see, this 1 0 is basically in decimal form. So in hex, when I write it, I will write it as A, and then B, and then C, and then D, and E, and F. So F basically represent the number 15 in decimal. Okay. And when I reach 16, it becomes 1 0 in hex. So I hope you know all these things. Uh, so let us quickly see some operations related to binary and hex. Say I'm trying to do some addition in binary. So say 1 0 and 1 1. So this 1 0 is 2 and 1 1 is 3 in decimal format. While these numbers 1 0, I have written it in decimal form. So if I need to add them, so 1 0 is 1 and 1 1 is 1 0. Okay, so which is basically 5 in decimal. Is it fine? So this is just to brush up your knowledge. I do hope that you all know all these things. Let us do one addition in say hex. So I would like you to answer my question here. Say I'm taking two numbers, 8AB and B78. Okay. And I'm interested in adding it. Okay. So what should I write here? B plus 8. What should I get here? Can anybody tell me?
Three.
Okay, it would be 3. Why it is 3? Because after B, I have to add 8 to it. So after B, I got C, D, E, F. A, so after B, C, D, E, and F, and then 1, sorry, 0, 1, 2, and 3. So in all, there are 1, 2, 3, 4, 5, 6, 7, and 8. So if I add 8 to B, I will reach this point, 1, 3. Okay. So I write 3 here and 1 would be carried. Fine. So what would be A plus 7 then?
Two.
It would be actually it would be 1, 1, 1. And if I add 1 to it, so it is 1, 2. So I write 2 here and 1 again gets carried here. And now B plus 8 again. So it was 1, 3. B plus 8 was 1, 3. So B plus 8 again would be 1, 3. And if I add 1 more to it, I get 1, 4. So this is what I get when I add these two numbers in X. Similarly, we can do subtraction also. Say, for example, I take two numbers, 5DC and 3AF. And I'm interested in subtracting these two numbers. This is in hex, and again, this is also in hex. So I have to subtract F from C. Now F is less, if F is greater than C. So what I have to do, I have to take carry from the left bit, immediate leftmost bit. Okay. Now carrying from here means I am carrying 16. Okay, it is not decimal in which we take 10 from here. We are rather taking 16 from here. Okay, so C is 12. The C is 12, and I am taking 16 from here, and then I have to subtract 15 from it, isn't it? F is 15. So if I do it, what I get? So I get 13. This is in decimal. These are all in decimal. So 13 is basically D. So what I have to write here? It will be D, isn't it? Okay. So what is left here? What is left here?
C.
C is left here. So C minus A is,
So Two. two.
it is 2. Okay, because C is 12 and A is 10. A is 10. So 12 minus 10 is 2, and in hex also we have to write the same number 2. And then 5 minus 3 is 2. So this is the representation in hex. So I would request you to just quickly brush up your knowledge of addition, subtraction, and even multiplication also. We can do multiplication also in hex and in binary. Okay, and even division is also possible, although it is bit mm, cumbersome, but still it is possible. So I would request you to kindly brush up your knowledge of addition, subtraction, multiplication and division of hex numbers, because more often we would be dealing with the hex numbers when we would be studying the 8051 microcontroller. Okay, so any questions till now? Okay, so now let's move further. Now let's take up the two, the microprocessor and microcontroller. Say I take up microprocessor first. It is more often called general purpose microprocessor. And then we have microcontroller. So as the name suggests, uh, both have got this common name micro. So micro definitely refers to something small. And one has got this processor term and the other has got this controller term. Uh, so these two basically refers to the various control operations or various processes that are carried out during the course of programming. Okay, so we need microprocessor or microcontroller because we need to do some programming. So the role of this is to execute certain program. Okay, now where do we use microprocessor and where we use microcontroller? Uh, One thing is clear, we use microprocessor and microcontroller in devices, in places where some programming is required. Okay, but there is a basic difference between the two structurally. So there is a structural difference between these two. In microprocessor, we have got uh, a CPU, and along with CPU, so this is the CPU, which is the basic component of a microprocessor. In short, we also call it mu P, and we call microcontroller as mu C. Then, since programming has to be carried out, those programs need to be stored somewhere. So we need some memory space. Okay, and in microprocessor, this memory basically reside outside the chip of the CPU in form of RAM and ROM. Okay, so this RAM and ROM, uh, they reside outside the chip of the microprocessor. Then we need to connect uh, the we need to actually give signals to some external world or take signal from the external world to the to the CPU so that it do the programming. Okay, and after programming it sends signal. So there need to be some interface between the CPU and the external world. So this is done with the help of the IO ports, input output ports. Okay, they are rather pins that are available outside the chip of the CPU, and wherein you can interface the external world. By external world, I mean say for sensors, or say a keyboard, or any type of device which need to be connected to the CPU. Either you take information from that external device, or you need to provide information to that external device. Let's say printer, you need to give information to the printer. So it could be any of the two. So you need input and output ports for it. And then there are some important peripherals, which are, one of which is called timer. It is also a hardware. This timer is also a hardware, and the basic role of a timer is to produce delay, or more specifically, what we call hardware delay. Since I am telling that there is a hardware delay, definitely there has to be some software delay also. I will come to that. But let us first now see just timer. Timer is a hardware which the role of is to produce delay. Okay, this is a peripheral which we require to be interfaced to the CPU of the microprocessor. Okay, why do we need timer? Definitely, in most of the control applications, uh, we want to give signal to the external world, or take signal from the external world after certain intervals of time. So that interval is generated with the help of this timer. It would be more clear when I would be discussing all of them in detail. Right now, I'm just talking about the structure. And then we also have a peripheral which is called serial communication port. Serial communication port. Okay, so IO port is for parallel communication, and serial port is for serial communication. So there are two types of communication that can happen between the processor and the external world. It could be either in the form of a series of instructions going out or coming in to the CPU. So one by one, one by one. So that is serial communication. And if they are transferred or received by the CPU in parallel fashion, then it is what we call parallel communication. So which one is faster? Definitely parallel communication is faster. But uh, in some of the applications, say for long distance communication, we cannot go for parallel communication, because then we need to have parallel uh, ports and pins and wires to interface the system to the external world, while we require only one wire to transmit and receive signals when we are using serial communication. So long distance communication definitely rely on the serial communication feature of the microprocessor. Okay, so microprocessor is this, and these are some of the peripherals and memories and ports that are connected in and around this microprocessor. Okay, so these are separate chips. These all are uh, put on one motherboard, what we call motherboard, which you have in a computer. Okay, but it makes the entire system very bulky. So what we do, we try to put all these things into one chip, in one single chip, into a single chip, and that we call a microcontroller. Okay. So in microprocessor, RAM, ROM, IO ports, timer, serial communication ports, they reside outside the processor. Processor is a chip, and rest of these peripherals and memory, they reside outside the chip of microprocessor. While in microcontroller, all these peripherals along with the memory, they reside within the chip. So the CPU is there, and along with CPU, these peripherals are also there within the chip. So this is one of the basic difference between a microprocessor and a microcontroller. Okay. So what advantage we get and what are the disadvantage associated with uh, keeping all these peripherals and memory and IO ports into the chip. So definitely, if I talk in terms of advantage, then all the thing become compact, isn't it? You all everything is in single chip. Okay. But what is the disadvantage? The disadvantage is that definitely the size of all these peripherals and IO devices and IO ports and RAM ROM, that needs to be very less. That is limited because they all have to be put into a single chip. Differently, the size of all these will be very small. Okay. and and definitely we again do not have the option or freedom to enhance the IO ports or the timers or serial communication. uh, Although there is some flexibility with the memory, that we can increase the memory of a microcontroller by connecting external RAM and ROM, but definitely we do not have the freedom to enhance these IO ports and timers, serial communication, etc. Okay. But even though we can increase the memory by certain amount in a microcontroller, it is nowhere near to what is there in microprocessor. Okay. So if I talk about 8051 now, so any doubt in this discussion? Any doubt in this discussion? Let me repeat once again that in microprocessor, this CPU reside within the chip, and this CPU is actually responsible for doing all the programming, okay, and executing the programs. Rest of the things like the memory, the IO ports, the timer, the serial communication, the interrupts, they all reside outside the CPU in a microprocessor. Okay. While in microcontroller, all these things reside within the microcontroller chip. All these things are in a single chip. Okay. And I told you what advantage we get when we pack all these things in one, that the system or the chip becomes compact. All the things are in one chip, while in processor, you require a motherboard. So there is a CPU, and around CPU, all these chips are fabricated. Okay. Now, any doubt? So let me just quickly move forward and talk about 8051 microcontroller. So if I talk about 8051 microcontroller, 8051 microcontroller has got 128 bytes of RAM of RAM and 4 kilobytes of ROM. So just you see the number. It's quite important. So, uh, 128 bytes of RAM. What is RAM and ROM? I hope you know this. ROM is read-only memory. This is random access memory. Read-only memory is actually uh, the permanent memory. The permanent memory wherein the codes or the programs are stored. And while RAM is a temporary or volatile memory. Volatile memory, okay, wherein datas which are processed during programming are stored. Okay, and as soon as you power off the microcontroller, this volatile memory or RAM, whatever there is in RAM, it gets erased, it vanishes. While ROM retains everything which is there in it. Okay, so so we want that the codes that is burnt in ROM to be present in it for all the time. Definitely, we do not want to write program every time we want to use a microcontroller. So the programs are stored in ROM. So that is why it's also called program memory. Program memory. While RAM is also called data memory. Okay. So I was just talking about these two numbers, 128 bytes and 4 kilobyte. So now we are talking about uh, data of the order of say terabytes, isn't it? Most of our system, 1 terabyte of memory space is there, and 4 uh, GB of ROM, and even 6 GB, 8 GB of RAM. Sorry, RAM is there in our laptops. Okay, so compared to these big numbers, this 128 byte and 4 kilobyte is nothing. But let me emphasize here that although they are nothing compared to these big numbers, but they are sufficient for microcontroller operation. Okay, I told you that since RAM and ROM reside within the chip of 8051, uh, so they have to be very limited, and it is as small as 128 bytes and 4 kilobyte in 8051. Okay, but still it is sufficient for its operation. And I will take up when we'll discuss programming, how it is sufficient to do most of our work. Okay, you see, microcontroller is used for specific applications. Okay, now let me just quickly write down here the difference between microcontroller and microprocessor. So this is a general purpose programming, and the example is your computer or your laptop or your mobile. Okay, while this is specific purpose device, and you will find it in say in AC in your home, or the washing machine, okay, or in your TV remote or AC remote, and in robotics. So microcontroller is everywhere, even in your home. You might not realize, but if you see deeply, you will find hundreds of microcontroller you are already using it, knowingly or unknowingly. But microprocessors, they are very few, one or two microprocessor, maybe in your laptop, in your computer. Okay, so intense programming is not required for microcontroller. It do only specific task. Okay, so that's why it do not require very large space, memory space for writing down programs and storing data. While microprocessor, they do variety of tasks. Just think of the various things that you can do in a computer. Okay, internet, games, and multiple applications and whatnot. So I hope you do appreciate the difference between these two and the applications of these two devices, the microprocessor and the microcontroller. Okay, so let me stop here and ask you if you have got any doubt regarding the lecture that I gave. Okay, now it's your turn. I will be taking up more about the microcontroller, specifically 8051, in our next lecture. Uh, Kindly let me know, is there any thing that you would like to ask me regarding whatever I delivered now? Yes, students.